Okay, now the first example. So here I'll read out the question first. So a coupling shown. Now what is a coupling? A coupling is some sort like, okay, a component is a component of the device which is used to connect, okay, two parts together. That means driving part and the driven part together in order to transmit force or to transmit power. That means if let's say for example you have two different shafts, if you want to transmit power from one shaft to another shaft, or if you want to transmit force from one shaft to another shaft, you need to have something to bind or to hold the two shafts together. Okay, you need a device which is used to hold both the parts together. Okay, that device we call a coupling. That used to couple, that means used to join two different parts together. They are called couplings. Now the coupling shown, okay, this is a coupling, okay, is constructed from steel of rectangular cross section, okay, and is designed to transmit a tensile force. That means to transmit the force from here to here. Okay, so if let's say for example you want to pull, okay, an object or a cart, okay, C-A-R-T, okay, and this part here is attached to, let's say, a cow or buffalo, okay, you want to pull something, okay, the cart to move. Okay, so you need to join one part, the driving part, to the driven part here by using these joints here, which is called a coupling. Okay, it is made up of steel. Okay, then is to transmit a force. That means a force here 50 kilonewton. A force here 50 kilonewton. Now there is a bolt of 15 mm diameter. So this is the bolt, 15 mm diameter. So this piece material here is rectangular. This is a rectangular piece of plate, and this is a fork, F-O-R-K. We call it a fork. Okay, so when you look from the top, okay, it gives you rectangular shape of both the pieces. This piece, dark blue, and this gray color piece, okay, is rectangular in shape. Okay, so with on the surface of both of this, there is a hole running through. So the hole is for this bolt here to be inserted so that it will lock these two parts, the blue color and the gray color, together. Okay, so that the force can be transmitted from this plate to the fork. Okay, and the bolt is 15 mm in diameter. This bolt here is circular. Okay, so the diameter of this bolt is 15 mm. So what happens is when you apply force here, now this bolt here will tend to be sheared into two parts. Will tend to be sheared into two parts. Okay, so there will be a shearing stress on the bolt. Remember, when you consider shear stress, the area and the force must be parallel. When you consider direct stress, okay, direct stress, shear stress and direct stress. Direct stress, the cross-sectional area, the area that is resisting the force, must be perpendicular to the line of action of the force. For shear stress, the contact area must be parallel to the line of action of the force. Okay. So first thing is you have to find the shear stress on the bolt. That means this part here. Then B, the direct stress on the plate. What is the direct stress here? And then C, what is the direct stress on the fork? Okay. So I will show you. Okay. That is the bolt that is running through the plate and the fork. Okay, this is the fork. This is the plate. Okay, and this is the bolt. Okay, so this length here is 50 mm. The thickness of this is 6 mm. The thickness of this is 6 mm. That means this thickness here is 6 mm, 6 mm, and the thickness of this is 10 mm. Okay, and the width is 50 mm. So from here you can see that is how the force is being applied. Now, solution. The bolt is subjected, the bolt, that means this part here, is subjected to double shear. Why double shear? So when you pull this force here, you can imagine that this bolt here, if let's say is unable to withstand these forces here, one place is going to shear here. That means it will cut through here. So if let's say, for example, this bolt material is too soft, okay, not too soft, that means it's not so strong enough to withstand the force. That means these two, let's say these two material is better strength than compared to the bolt. So what happens when you exert the pull here? This part here, look at the pointer. This part here and this part here will be sheared. Will be sheared. That means will be cut. Okay, here I show you. So the force that is applied, okay, this 50 here. So you can split them to 25, 25 because you have the fork here and the fork here. Okay, they have the fork here. And this is the plate here. So what happens when the bolt is subjected to these forces? It will be sheared like that. Okay, it will be sheared in this manner. Okay, the bolts. So what happens is, let's say if I want to find the shear stress here. So I must of course know the force. Okay, 50 is 50, not 100. Okay, remember equal and opposite action and reaction. Yeah, equal in magnitude, that means 25, and 25 is going towards the right, and this 50 is going towards the left. So the magnitude of the force is 50 kilonewton only. So the force 50 kilonewton, you have to divide by the area, the cross-sectional area of this bolt here. Remember, it's double shear. You see, it is sheared into two parts like that. So you see this line here is where you have one shear, and this line here you have the second shear. So it's double shear. So the area that you consider has to be double. The area that you consider has to be double. So what is the area of this bolt here? So it is a circular bolt. How do you know it's circular? Because they give you diameter. So 15 mm. So remember, convert this to meter first. Convert this to meter. So it is 0.015 meter. So that is the diameter. So you have to use the formula for area of circular cross-section. Area of circular cross-section is either you use pi r square, where r is the radius, or you use pi d square over 4. So remember, so the shear stress will be the force divided by the area. Remember, for shear stress, the area that we consider has to be parallel, okay, or transverse, being transverse to the direction line of action of the force. So the area, okay, you can imagine the area will be the cross-sectional area of the bolt, which is given as pi r square. So I'm using pi r, I should be using pi r square or pi d square over 4, or pi d square. This is the diameter, so the 4 is on top here. Pi d square over 4, okay? So times 2, why times 2? Because it's double shear, double shear. So when you take the force, divide by the area, divided by 2, because it's double shear, because it's 2 times the area. So you got the shear stress. Okay, that is 141.5 megapascal, the shear stress that is on the bolt. Okay, so that is yes, yes. Can you ask me after? Can you ask me afterward?
Okay.
Okay, can you ask me afterward? Okay. Now, then the next part, remember the line of action of the force must be adjacent or parallel to the contact area. That is for shear stress. So I put a notification, a note here, okay, for you to remember what we have done for the previous section. Sorry, I answer you afterward your questions, yeah, because we are doing the recording for you all so that you all can refer to this later on. So then part B, the plate which will be subjected to direct tensile stress. So part B here, you have to find the direct stress on the plate. The plate is this. So if let's say, for example, now the bolt is strong, the fork is strong, but the plate is weak. So when you apply force like this, there is a possibility that the plate will break across the line of action of the force. So that is why the area that we consider must be, the contact area must be 90 degree or being perpendicular to the force. Okay, so this is the plate. Let's say I draw out the cross section of the plate. So the area, what is this area here? So what is the thickness of the plate? What is the thickness of the plate here? 10 mm. What is the width of the plate? 50 mm. So the force 550 kilonewton. So what is the direct stress? Okay, remember again, for direct stress, the area, the contact area must be perpendicular or 90 degree to the line of action of the force. Okay, so you have the force or the load divided by the area. The load or the force is 50 kilonewton. That is why you times 10 to the power of 3. The area, okay, so you see, okay, I have 10 power of -6 because I am converting it from mm square to meter square. I am converting it from mm square to meter square. So that is what is 10 power -6. So 50 mm, and 50 mm, and I think I put wrongly. This should be 10 mm. Yeah. Afterward, you all slightly do a correction for me. Yeah. When you all redo this example that time, this should be 10 because you are referring to the plate. And our plate here is 10 mm. So you put a 10 here. Okay, 10. Remember everyone? 50 is this 50 mm. That means the width. The thickness of this should be 10 mm here. Okay, I put a 6 here because I think I have overlooked this. This is the thickness of the fork, the plate. Okay, so this value will be different. Yeah, please change this to 10. Yeah, the 10 because this is thickness 10 mm here. So that is part B. Then part C, the force in the coupling, okay, or the fork is shared by, the force in the coupling is shared by both the fork end, So here, this force is shared by the force is shared by both of these here, the fork. So that is 25 and 25. So 25 and 25. So you have the stress goes to force over area. So the force here is 25. So 50 times 6 area. So this is 50, this is 6. So this is correct, this is wrong. Yeah, this is 10, this is 6. Okay, so you've got 83.3 megapascal. So that is the answer for section A, B, and C. Okay, everyone.